Understanding the electrical specifications of a rooftop unit is crucial for safe and efficient operation. Firstly, let's address the voltage range of 208/230 volts. The rooftop unit is indeed designed to operate at either 208 volts or 230 volts. The amperage does not necessarily need to change when switching between these voltages. This is because the unit's motor is designed to operate efficiently within this voltage range, maintaining a relatively consistent power draw. The motor and other electrical components are engineered to compensate for the slight voltage difference, ensuring proper performance without requiring a recalibration of amperage. Secondly, the term minimum circuit amps, often abbreviated as MCA, refers to the minimum amperage rating required for the circuit breaker or fuse that protects the circuit feeding the rooftop unit. The MCA value, in this case 28 amps, is the lowest acceptable rating for the overcurrent protection device. This rating is chosen to prevent nuisance tripping of the breaker or fuse during normal operation, while still providing adequate protection against overloads. If a breaker or fuse with a lower amperage rating is used, it may trip unnecessarily due to the normal current draw of a unit, especially during startup or periods of high demand. Thirdly, maximum rated amps indicate the maximum current that the rooftop unit is designed to draw under extreme or abnormal conditions. This value, often significantly higher than the normal operating current, accounts for situations such as motor starting in rush, temporary surges, or fault conditions. The high maximum rated amps ensures that the unit can handle these temporary increases in current without causing damage to its components or tripping the circuit breaker. The difference between the minimum circuit amps and the maximum rated amps reflects the range of current the unit may draw under different operating scenarios. The minimum circuit amps ensures that the circuit is adequately sized for normal operation, while the maximum rated amps provides a safety margin for handling transient events. Fourthly, overcurrent protection at the disconnect is a critical safety measure, even when a circuit breaker already protects the circuit at the main panel. The disconnect switch, typically located near the rooftop unit, provides a local means of isolating the unit from the power supply for maintenance or emergency purposes. The overcurrent protection device at the disconnect, such as a fuse or circuit breaker, offers an additional layer of protection against overloads and short circuits. This local protection is particularly important because it can quickly interrupt the current flow in the event of a fault within the unit, minimizing the risk of damage or fire. The maximum overcurrent protection rating, 45 amps in this instance, is higher than the maximum rated amps to ensure that the disconnect can handle the inrush current during motor starting and other temporary surges without tripping unnecessarily. However, it is still low enough to provide effective protection against sustained overloads or short circuits. The overcurrent protection device is designed to trip before the unit's components can be damaged by excessive current, providing a critical safety function. Fifthly, the load on the rooftop unit may never exceed approximately 25 amps under normal operating conditions. This is because the unit is designed to draw a maximum of 23.4 amps as stated in its specifications. This value represents the highest current the unit will draw under optimal operating conditions, such as when the compressor is running at full capacity and the fan motors are operating at their maximum speeds. The actual current draw will typically be lower than this value, depending on factors such as the ambient temperature, the thermostat setting, and the load on the cooling or heating system. It is important to note that the maximum rated amps is a theoretical maximum, while the actual operating current will vary depending on the specific conditions. Regular monitoring of the unit's current draw can help identify potential problems, such as a failing compressor or a clogged air filter, which can cause the current to increase beyond its normal range. Sixthly, some disconnects do incorporate built-in circuit breakers. These combination disconnects and circuit breakers provide a convenient and compact solution for both isolating the unit from the power supply and providing overcurrent protection. The built-in circuit breaker is typically a non-adjustable type, meaning that its trip current is fixed at a specific value determined by the manufacturer. This value is chosen to be appropriate for the specific rooftop unit, providing adequate protection against overloads and short circuits without nuisance tripping. The combination disconnect and circuit breaker simplifies installation and maintenance by combining two functions into a single device. It also ensures that the overcurrent protection is properly sized for the unit, as the breaker is specifically designed for that application. It is essential to verify that the built-in circuit breaker has the correct amperage rating for the rooftop unit before installing the disconnect. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits and equipment from damage caused by excessive current. They operate by interrupting the current flow when it exceeds a predetermined threshold, preventing overheating, fires, and equipment failure. Circuit breakers are resettable devices that can be manually or automatically reset after tripping, while fuses are single-use devices that must be replaced after they blow. The selection of the appropriate overcurrent protection device depends on the specific characteristics of the circuit and the equipment being protected. Factors to consider include the amperage rating, the interrupting capacity, and the time current characteristics. The amperage rating of the overcurrent protection device should be chosen to protect the circuit and equipment without causing nuisance tripping. The interrupting capacity is the maximum current that the device can safely interrupt without failing. The time current characteristics describe the relationship between the current and the time it takes for the device to trip. These characteristics are designed to allow for short duration overloads, such as motor starting in rush, while still providing protection against sustained overloads. In summary, understanding the electrical specifications of a rooftop unit is essential for ensuring its safe and efficient operation. The voltage range, minimum circuit amps, maximum rated amps, and overcurrent protection ratings are all important factors to consider when selecting and installing the unit. By following the manufacturer's recommendations and adhering to applicable electrical codes, you can ensure that the rooftop unit operates reliably and safely for many years. Regular inspection and maintenance of the electrical components can help identify potential problems early on, preventing costly repairs and downtime. The National Electrical Code, or NEC, provides comprehensive guidelines for the safe installation and operation of electrical systems. It covers topics such as wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated every 3 years to reflect the latest technological advancements and safety standards. Compliance with the NEC is essential for ensuring the safety of people and property. Article 440 of the NEC specifically addresses the requirements for air conditioning and refrigeration equipment. This article covers topics such as disconnecting means, overcurrent protection, and motor circuit conductors. Article 440 provides detailed guidance on the selection and installation of electrical components for HVAC systems, ensuring that they are properly protected and operate safely. It is important to consult the NEC and other applicable codes and standards when working with electrical equipment. Proper training and certification are essential for electricians and other professionals who work with electrical systems. Understanding the principles of electricity and the requirements of the NEC is crucial for preventing electrical hazards and ensuring the safety of people and property. When selecting a disconnect switch for a rooftop unit, it is important to choose a switch that is rated for the appropriate voltage and amperage. The disconnect switch should be able to safely interrupt the maximum current that the unit can draw under fault conditions. It should also be readily accessible for maintenance and emergency purposes. Disconnect switches are available in a variety of types, including fused and non-fused switches. Fused disconnect switches incorporate fuses that provide overcurrent protection, while non-fused switches rely on a separate overcurrent protection device. The choice between a fused and non-fused disconnect switch depends on the specific application and the desired level of protection. Grounding is an essential safety practice that helps to prevent electrical shock. It involves connecting the metal parts of electrical equipment to the earth, providing a low impedance path for fault current to flow back to the source. Grounding helps to ensure that overcurrent protection devices will trip quickly in the event of a fault, minimizing the risk of electrical shock. The NEC provides detailed requirements for grounding electrical systems. It specifies the types of grounding conductors that must be used, and methods of connecting grounding conductors, and the requirements for grounding electrodes. Proper grounding is essential for the safety of people and property. Regular inspection and testing of grounding systems can help identify potential problems and ensure that they are functioning properly. Electrical safety is a critical concern in all aspects of electrical work. It is important to follow safe work practices and to use appropriate personal protective equipment, such as gloves, safety glasses, and insulated tools. Electrical hazards can be deadly, so it is essential to take all necessary precautions to prevent accidents. Lockout-tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. These procedures involve disconnecting the equipment from the power supply, locking the disconnect switch in the off position, and tagging the switch to indicate that the equipment is being worked on. Lockout-tagout procedures help to ensure the safety of workers who are performing maintenance or repair on electrical equipment. Regular training on electrical safety practices is essential for all workers who may be exposed to electrical hazards. This training should cover topics such as the dangers of electricity, safe work practices, and the use of personal protective equipment. By following safe work practices and taking all necessary precautions, you can help to prevent electrical accidents and ensure the safety of people and property. Understanding the electrical specifications of a rooftop unit is just one aspect of ensuring its safe and efficient operation. Regular maintenance, proper installation, and adherence to applicable codes and standards are all essential for maintaining a safe and reliable HVAC system. By working with qualified professionals and following established best practices, you can ensure that your rooftop unit operates safely and efficiently for many years to come.